Hi guys, welcome back. I am Darshan from Sri Venkateswara College of Engineering, Department of CSECY. Now we discuss about the topic is rectangular pulses in mathematics. Introduction to rectangular pulse. A rectangular pulse is a type of signal that has a constant amplitude for a specific duration. It is often used in digital communication systems and signal processing. The rectangular pulse is characterized by its pulse width and its pulse height. Pulse width and pulse height. Pulse width refers to the duration of the time that rectangular pulse remains at its maximum amplitude. Pulse height, also known as the pulse amplitude, is the maximum value of the rectangular pulse. The pulse width and pulse height can be adjusted to meet specific requirements in the signal system. Ideal rectangular pulse. An ideal rectangular pulse has a pulse width of 0 at beginning and end and a constant pulse height within the duration. The ideal rectangular pulse has a infinite bandwidth, meaning it contains all frequencies. In practice, it is not possible to generate a true ideal rectangular pulse due to limitations in signal generation and transmission. Pulse duty cycle. Duty cycle of duty cycle of a rectangular pulse is the ratio of the pulse width to the total period of the pulse. The duty cycle of 50% means that the pulse is on for half of the period of and offered to the half. The duty cycle can be adjusted to control amount of time the pulse is on versus off. Applications of rectangular pulse. Rectangular pulses are widely used in digital communication system for encoding and decoding information. They are also used in pulse width modulation (PWM) techniques for controlling power in electronic devices. In signal processing, rectangular pulses are used for filtering, sampling, and shaping signals. Pulse rise and fall time. The rise time of rectangular pulse refers to the time it takes for the pulse to transition from a low to high amplitude. The fall time is the time it takes for the pulse to transition from a high to low amplitude. The rise and fall time of a rectangular pulse can affect the overall quality and integrity of the signal. Signal to noise ratio. Signal to noise ratio is a measure of the strength of a signal compared to the level of background noise. For rectangular pulses, a higher SNR is desirable to ensure accurate and reliable signal transmission. Various techniques such as error correction, coding, and noise filtering can be employed to improve the SNR of rectangular pulse signals. Pulse shaping techniques. Pulse shaping techniques are used to modify the waveform of rectangular pulses to meet specific system requirements. Common pulse shaping techniques include Gaussian shaping, raised cosine shaping, and sinc shaping. These techniques help to reduce intersymbol interference and improve the overall spectral efficiency of rectangular pulses and signals. Limitation and challenges. Rectangular pulses are prone to intersymbol interference, where symbols from adjacent pulses overlap and cause signal distortion. Generating and transmitting ideal rectangular pulses is challenging due to limitations in signal processing and transmission technology. Designing systems that can accurately detect and decode rectangular pulse signals in the presence of noise and interference is a complex task. Summary and conclusion. Rectangular pulses are widely used in digital communications systems and signal processing. They are characterized by pulse width, pulse height, duty cycle, rise and fall time, and the signal to noise ratio. Pulse shaping techniques and error correction coding play a crucial role in improving the performance and reliability of rectangular pulse signals. Jai Shri Ram.